Hello guys, and welcome back to the show. So in the last video tutorial, we saw how to integrate Kafka into our application. We created a Kafka producer, which basically publishes the events that we emit to our server into a Kafka topic. And then we integrated a Kafka consumer, which basically consumes that event. And currently what it does is that it prints that event into the console. But today what we are going to do is to integrate Elasticsearch into our application so that we can store that event into an Elasticsearch index. And an index is basically a database in the relational database world. If you don't know what Elasticsearch is basically a database which allows us to search for the things that we store in that data more efficiently. So we say that Elasticsearch is a distributed search engine with real-time analytics. Okay, it allows us to run full text search on the data that we store in it. To integrate Elasticsearch into this application, what we can use is the Elastic4s ElasticSearch Scala client, or we could use the high-level Java REST client. So what I'm going to use actually is to use this one. Okay, so I'm here on Maven repository and I'll look for a version of Elasticsearch. So I will actually use this one. Okay, I'll go into SBT, then I'll copy this, then I'll come over here, paste this here, and I'll say val Elasticsearch client, and this will be this, like so. Then I'll say private val Elasticsearch version, which will be this. Then I'll copy this, then I'll use this like so. Then let's build this and let's see what happens. So build was successful, and I've also gone ahead and added Elasticsearch client as a dependency inside of the event store module. So now we have everything sorted. So what we can do is to go into our application. So let me actually close all of these so we have a bit more space. So we have our server here. What I want to do is that I want to add the Elasticsearch client as part of the application lifecycle. What do I mean by this? I want to have just one client. Okay, so as you can see, I have a config which I pass to the application, and then that is it. I do not pass the config anywhere else. Okay, I want to do the same thing for the ElasticSearch high-level client. So I want to create a client and basically pass the client to the stream like we do for the config, and then use it internally within my application. So what I'm actually going to do is to go into the project, go to core, let me close this, and inside of core I'm going to create another directory, and I'll call this directory Elasticsearch. And inside of this Elasticsearch, what I'm going to do is to create an algebra for the ElasticSearch client. Okay, so I'm gonna go over here, then I'll create an object, then I'll call this ElasticClientAlgebra. Now let us have a look at the documentation and see how we can create a client for Elasticsearch. So according to the ElasticSearch documentation, it says that a REST high-level client instance needs a REST low-level client builder to be built as follows. Okay, so I need to create something like this in order to have a REST high-level client, and then I need to also close it because it is a connection or it's a resource that when I finish using it, I need to close it. Okay, so let's go back into application. I'm going to create a trait called ElasticClientAlgebra. So I'll create a trait, I'll call it an ElasticClientAlgebra. This will have an effect type like so, and what I'm going to do is to define a client. And actually what I want the client to return is a resource. Okay, so I want to return a resource of type REST high-level client. So I'll say I want to return a resource of type F and REST high-level client like so. Okay, so in cat effect, a resource is something that you can acquire and then close. So you can acquire and then release it after you finish using it. Okay, so what I'm going to do is that I'll create a method called IPLM, which is how I define implementation. And this implementation will take an effect type of type async like so. And then this will be a new Elasticsearch client algebra. Then I need to define the client. I can get rid of the override because this has not been implemented. So I have the client like so. I need to provide the effect type over here. So I'll provide the effect type as well here. then I have this. So what I can say is that resource.make, and what resource.make does is that it creates a resource from an acquiring effect and a release function. Okay, so I need to provide it an f of a, which it can acquire, and then it can release after it has finished using that resource. Okay, and the resource that I want to acquire is the RestHighLevelClient. So what I'll do is that I'll say resource.make, then I'll say async, because we have the async type class here in scope, the delay, and over here I'm going to create this. Okay, so I'll basically copy this, go over here, and then paste this here. So I'll say new RestHighLevelClient, then I need to import the REST client builder, then I need to import the HTTP host. So I just need one for this tutorial. I'm not going to have more than one, and I have this. And now what I need to do is to provide what it should do to release. Okay, I need to provide it a function that will take an A and then return an F of a unit. Okay, so what I'm going to do is to basically create a client over here and then say that async of type F dot delay client dot close, like so. So now we have an algebra for the RestHighLevelClient. But as you can see again, we are hard coding the host name, the port, and the scheme. Okay, we can do better. We can have a config for Elasticsearch and then add it to the main configuration and then pass it to the Elasticsearch client, which I think is best if we do that. Okay, so since we've done it twice now, I'm gonna go ahead and do it, and then we can have a look at it. So I've gone ahead and created an ESConfig. The ESConfig is basically a type, a case class, which has an index, and an index is basically in the relational database world, it will be like a database. Okay, and then I've got shards. So in Elasticsearch, we have something that we call shards. Okay, so you can think of a shard as a container which contains a piece of the data that we store inside of the database. They are actually the things that store the data that we put in an Elasticsearch index. And shards have replicates, and these replicates are there so that if the shards fail, if a primary shard should fail, we can make query to the replica. So over here I have an index, host, port, scheme, shards, and replicates. And then what I'm going to do is that I'm going to name the default index an event index. The port is 9200, the host is localhost, the scheme is HTTP, and I'm saying that the number of shards should be 3 and the number of replicates should be 2. So I'll have 3 primary shards and I'll have 2 replicates for each of the primary shards. And then I have the ESConfig over here, like we did for the Kafka config and the server config. So now what I'm going to do is that I'm going to go into the config, and over here what I'm going to do is to copy the ESConfig like so, and then do the same thing that we did. Okay, so I'm going to say ESConfig dot of type F. Actually, let me make this a def, which will take in an F type, async, and then let's put an F here because we don't want to specify the effect type. Okay, so let me import cat effect async over here like so. So if I go back to the config, I can pass it the F type, then I can say ESConfig, then I can pass it the ESConfig nicely here like so. And also I need to pass ESConfig here, and this will be of type ESConfig. The next thing I'm going to do is to actually create the algebra that we can use to interact with Elasticsearch. So we actually need to create an Elasticsearch index. Okay, we need to actually create the database in Elasticsearch, and we need to actually store data into Elasticsearch. So let's create an algebra that will allow us to create the Elasticsearch database when our application starts, and then store data into Elasticsearch. And inside of Elasticsearch, what I'm going to create is an ElasticSearchAlgebra, okay, or an ESAlgebra. So I'm going to create a trait, and I'll call this trait ESAlgebra. And what this ESAlgebra will have an effect type. Then it will have 2 methods, right? One is to create the index, and one to put events into the index. So store data into an index. Okay, so I'll say def create index, and this will basically return an F of a unit because we just want to create the index and nothing else. Okay, and the second one will be to index the record. So I'll say def store, I'll pass it an event, and this event will be of type event, like so. And for now, I'll put an f of a unit over here because I just want to store. Maybe later on we can change it to something else. The next thing I'm going to do is to create an object. I'll call this object ElasticSearchAlgebra. I'll define an implementation. I'll pass it the effect type and an async of that f. If we look at the documentation on how to create an Elasticsearch index, as you can see over here, this is the documentation of how to create an Elasticsearch index. We create a new index and we pass it the name of the index. Okay, so the name of the index will be inside of our Elasticsearch config. Okay, so I need to pass in the Elasticsearch config over here. Then I can specify the number of shards and the number of replicas over here. And if I want to do a synchronous execution, as you can see, I need the client. So I need to pass it the RestHighLevelClient so that I can actually create the request. Okay, so I know that I need to pass in the RestLevelHighClient and also the ESConfig. So what I'm going to do is to say ESConfig of type ESConfig, and then I'll pass in the RestHighLevelClient, or I'll say RestHighClient, like so. And this will be a new ElasticSearchAlgebra of type F. Then I can provide it those two methods. So I'll define create index, then I'll define store, like so. Let me get rid of the override because we haven't actually implemented these methods inside of the traits. Okay, and let me put in the type annotation for this method, like so. So now to create the index, what I'll do is that I will basically go to the Elasticsearch documentation and just copy this. Okay, actually I'm going to put this in a separate method. So I will define a private method over here inside of the Elasticsearch package, and this method will be called create index request. So I'll call it create index request. Then I'll just put this over here, like so. The name of the index will be esconfig.index.name. Then I'll go back to the Elasticsearch documentation. Let me remove this first. I'll copy this. I'll come over here. I'll paste this here. So I will say .settings, like so. I will import this over here. Then this value will be esconfig.shards.value. And this will be esconfig.replicas.value, like so. And if we check the return type for this will return a create index request. But as you can see, if we are creating an index, right, this might probably fail, you know. So we need to wrap this inside of an effect. So I'll say async of type f.delay, because even if we click on create index request, as you can see, this might throw an error. Okay, it might cause a side effect, and we don't want that. So now I have a create index request. So I can go into the create index. Then what I'm going to do is to have a for comparison. Okay, and then I will say request will be this create index request. Then I'll have a yield over here, like so. And let me import cats.implicit. So import cats.implicit, like so. One thing that I need to mention is that when we create the index, the first time we create the index, it will work. Okay, because the index does not exist. But if the index exists, right, and we start the application again, this will try to create the index again, and this will throw an error. So what we can do is that before we actually create the index, we can check if the index already exists, and if it does not exist, we create the index. If it does exist, we don't do anything. Okay, so I'm going to have another method over here which we'll call get index request. So this get index request will basically go onto Elasticsearch and ask Elasticsearch, hey Elasticsearch, do we have any index with this name? And if we do have the index, it will return true. We do not have the index, it will return false. So what I'm going to do is to create a method over here. This will be inside of the Elasticsearch package as well. Then I'll call this method get index request, like so. And this get index request will return an f of get index request. Okay, so I'll do an f of get index request, and all it will do is that it will return an async of type f dot delay new get index request. Then I'll pass it the esconfig dot index dot name. So all this will do is that it will go again onto Elasticsearch and be like, Elasticsearch, do you have any index with this name? Okay, and if the index does exist, I'll get a true. If it does not exist, I'll get a false. So now, before we actually create the index, what we are going to do is to check if the index does exist. So I will say get index like so. And this will return a get index request. So we actually need the REST high level client to make a request and check if the index does exist. So I'll say index exists like so. And this will be an async. I'll type f.delay REST high level client dot indices like so. And there is this method called exist. Then I'll pass it the get index, which is basically what is returned over here. Then I'll pass it the request options.default like so. So if we actually click on this, the request is the get index request, and then the request option, which is the request option.default that I passed to it. Okay, so if I go back to the ElasticSearchAlgebra, now I can say that if the index does exist, I want you to just print to the console that the index exists. If it does not, what I want you to do is to create the index and then print to the console. So let me add the console type class as well over here. And then what I will say is that index exists dot pure of type f dot ifm. And what this does is that I can pass it two options. If true, what I want you to do. If false, what I want you to do. Okay, so what I want you to do, if true, is that I want you to print to the console. So I'll say console. Let me import from Cactifect like so. So the print line already exists. If it does not exist, what I want to do is to actually create the index. Okay, so what I'll do is that I'll say async the delay REST high level client dot indices dot create. Then I can pass it the request. So this request options.default like so. And then once this is done, what I want you to do is to print to the console as well. So I'll say console.println index with the name esconfig index.name has been created. So in short, this is what I want. When I want to create the index, I first want to check if the index does exist. Okay, this will return a boolean. So it return a boolean, as you can see. And I left this into an f. Then I call the .ifm method, which basically gives me the option to pass a function that should be executed if the boolean is true, and a function that should be executed if the boolean is false. Okay, and I'm saying that if the boolean is true, meaning that the index already exists, I want you to print to the console that the index already exists. It does not exist. What I want you to do is to create it and then print to the console that index with the name has been created. So that is it. Okay, this is how we are going to create the index. The next thing that we are going to do is to actually store. Okay, so we create the index, the database exists, we need to store the data, the record that we sent into that index. And we can store that by also going to the Elasticsearch documentation. And as you can see from the Elasticsearch documentation, in order to store something, store data into an index, you can use this API. Okay, you send a new index request, you provide the name of the index, and then you can have options to basically send a synchronous execution or an asynchronous execution. For the sake of this tutorial, what I'm going to do is to use the synchronous execution. So I'm going to use the RestHighClient.index, then I'll pass it the request, and I'll pass it the request options. Okay, so what I'm going to do is to get back here and then say that async of type f.delay like so. Then I'll say RestHighLevelClient.index new index request. I'll import this, and basically what I'll pass to this is the index name. So I'll say esconfig.index.name, which is the index name, and the next thing that I need to pass it is basically the events that I want to store, the data that I want to store, which is this event. So I'll say .source, and what I want to store is this. Okay, so I'll say event dot as JSON. I'm going to store it as a string in there. So import io, the source, the syntax to have the as JSON method. So dot as JSON, no spaces. So it's new index request. This is the name of the index. Then I need to provide it a JSON string, which is what I just did. Then I need to provide it the X content type, which is this. So I'll come over here. Then I'll add this here as well. Then I need to import this. Then the last option that I need to provide it is the request option. The default like so. Okay, so now let's build this and let's make sure that it compiles. Okay, everything compiles. So now what we are going to do is to actually use this instead of our code. To do this, what I'll do is to go into our main, and inside of the main, what I'm going to do is to initialize the client, okay? And then pass everything to the server. So I'll say ES_client, and the client will be a stream.resource. And what I need to pass to the stream.resource is basically the ElasticSearchAlgebra.client. Okay, so what I'm going to do is to go to the main, and I'll say ElasticSearchAlgebra.implementation. I'll pass it of type IO, and I'll say .client, like so. So now I have the RestHighLevelClient over here. And what I'm going to do is to pass the ES_config to this, okay? Because if I go in here, I have the host name, the port, and the scheme being hard-coded over here, all right? But we have that in the ES_config. So all I need to do is that implementation, I'll pass you an ES_config. So I'll say ES_config, and then over here, I can say ES_config.host.value. Then I can also say ES_config.port.value. Then I can also say the same thing for the scheme. So I can say ES_config.scheme.scheme, like so. So now instead of the main, I can pass it the ES_config like so, ES_config.ES_config. So my bad, so it should be like this, okay? So I have the ES client over here. The next thing I'm going to do now is to add the ES algebra. So I'll say ES algebra, and this ES algebra will basically be the ES algebra. So it will be this ES algebra. Then I'll call the implementation method. So I'll say dot, then I'll pass it the effect type, which is of type IO. And as you can see, this needs an ES_config and a RestHighLevelClient. So I'll go over here and I'll pass it the ES_config. So I'll say config.ES_config, and this is the client. Actually, let me call this RestHighLevelClient, okay? So I'll say RestHighClient, and this RestHighClient is what I'll pass over here. But as you can see, this basically returns an ES algebra of type F. So what I need to do is to wrap it inside of a stream. So I'll say stream.emit. I'll emit a stream of this. Now the last thing I need to do is to basically pass the ES algebra to this stream. So I'll go into the stream, and inside of this stream, what I'm going to do is to say ES algebra will be a ES algebra of that type F, like so. And then I'll go back to the main, then I'll say, hey, I'll pass you the ES algebra, like so. Now, thinking of it, I could basically have a service that will take in the RestHighLevelClient, the ES algebra, and the consumer. And this algebra will basically handle the process of consuming the event from Kafka and then indexing that event or indexing that data into an Elasticsearch index. And that is exactly what I'm going to do. But before I do that, what we need to do is to create the actual index. So we can say over here that the stream.eval ES algebra.create index, like so, which will basically create the Elasticsearch index. Okay, so the last thing I'm going to do is to go over here, and inside of the core, what I'm going to do is to create a new package. Then I'll call this package service. And what this service will do is that it will have an object called index service. And I'll create a trait over here. Let me call this trait index service as well. And all this will do is that it will have a method called persist. Okay. And what this method would do is to return a stream. So let me import fs2.stream, and it will return a stream of type F and an index response. Okay, and then what I can do is that inside of the implementation, I'll take in an effect type and an async. Then I'll pass in the consumer algebra. So if I go to my Kafka, I have this Kafka consumer algebra. So this consumer will be of this type. Okay, so if I go over here, so I can say Kafka consumer algebra, and this Kafka consumer algebra of type F. Then what I will need is that I need to pass it the RestHighLevelClient. Okay, so I'll say REST, which will be of type RestHighLevelClient. And then the last thing I need to pass it is the ES algebra. Okay, so it is this algebra. So if I go into the ES, I have this ES algebra. So I will say that it will take in an ES algebra. So ES algebra of type ES algebra of type F, like so. Okay, So this is what the implementation will take. And this implementation will be a new index service of type F. I'll define the persist method over here. And this persist method will basically say that Kafka consumer algebra dot consume dot eval map chunk consumed event, and the consumed event, so this is consumed event, okay, and the consumed event will basically be ESAlgebra dot store, okay, because we want to store the event that has been consumed, right? So it's ESAlgebra dot store consumed event dot record dot value, like so. Now say dot eval tap chunk, because I want to know if indexing has been successful. So I will say index response, and this index response will basically log to the console, okay? And I can add the console type class, like so. I'll import this from Cactifet. I'll say console of type F dot println the index status is index response dot status. And actually this is a unit, and it's a unit because my store method returns a unit. What I could do, okay, that makes perfect sense. Okay, so my store method returns a unit, but I want to know the response of the index. Okay, I want to know if indexing has been successful or not. So if I go to store, I could return an index response. Okay, so I could say index response, like so. And I can come over here, then I can change the type to an f of index response. Okay, so if I go back to the index server, now I have an index response. Let me get rid of the type. I can say index response.status, like so. Okay, so now I have this. And I actually did not need the REST high level client. So now we have everything sorted. What I'm going to do is to pass the REST high level client to this, okay, to the stream. So I'll say REST high level client. And now I can say REST high level client of type REST high level client, like so. And since I'm passing the REST high level client to the stream, what I could do, okay, is to remove this. I do not need this over here. I do not need this over here, okay? So I do not need this. And I do not even need to pass the ESAlgebra to the server. So I'll only pass the config and the REST high level client to the server. And inside of the stream, what I'm going to do is to have an ESAlgebra, which will basically take in the config.esconfig and then the REST high level client, like so. So now I have the ESAlgebra. And since I have the ESAlgebra, what I'm going to do is to create the index. Okay, so what I'm going to do is to say stream.eval ESAlgebra.create index, like so. And this has to be of type F, and this has to be of type F, like so. So now I've created the index using this ESAlgebra. So I know the index is created. Once the index has been created, the next thing I'm going to do is to basically store data into the index. So I basically copy this and I will say that index service dot the implementation, I'll pass it the effect type, which is F, and then this will take in a Kafka consumer algebra and then the ESAlgebra. Okay, so I'll pass it the Kafka consumer algebra, and this is the Kafka consumer algebra. So I'll pass it the Kafka consumer algebra, and then I'll pass it the ESAlgebra as well. And actually what I could do is to move this whole ESAlgebra thing over here as well. Now, instead of saying Kafka consumer algebra.consume, what I will do is to say index service dot persist. Okay, so let me build this and make sure that everything builds successfully, and then we can actually run and test this. So everything is building successfully, but we do not have Elasticsearch installed on our machines, so we need to modify the Docker Compose file and add configurations for Elasticsearch. So I'm going to go ahead and add that. Okay, all right, so I've gone ahead and added an Elasticsearch image, and you can find the source code to this tutorial in the video description so that you can also copy the Docker Compose file and everything inside there, and then use it as well. So now we have a Docker Compose file with all the images that we want, so we can actually run this and test this to make sure that everything works. Now let us test our application and let's see if it actually works. So I'll go to the terminal, and from the root of the application, I'll run the Docker Compose app command. So the Docker containers are running. I've started the server, and as you can see, I got this log that the index with the name event index has been created. So now let us see if we are actually able to index into Elasticsearch. So what I will do is to run our test server.sh script. Let's see if we get the logs that we want. Okay, this has been run. Let's look over here. And as you can see, we got record has been processed, and we got the index status is created, which means that we are 100% sure that the message has been indexed into Elasticsearch. Let us query Elasticsearch and let's see if we can actually find this index. So I'm going to send a curl request to the Elasticsearch endpoint _cat. Then I'll pretty print that to the console. And as you can see, we can check all the indices using this command. So I'll send another curl request, but this time what I will say is I want this. Okay, I want all the indices in the Elasticsearch cluster, and as you can see, I've got the event index and it says that the status is yellow. So basically in Elasticsearch, the health of an index can be red, green, or yellow. Green means that all the primary shards and all the replicates are up, they are all working. Yellow means that all the primary shards are working, but some of the replicates are down. And then red means that some of the primary shards are down. But I'm getting yellow for now. It's okay. I'm not really interested in that. So what I can do is to search for all the things inside of the event index. Okay, so I can say I want to query this event index and I want that search like so. Then let me pretty print this like so. And what I actually have inside of the index is this. So I've got Beatrice, mood is I feel great, and then what I plan to achieve is tomorrow I want to just sleep. And that is exactly what we have inside of our test server. We can actually modify our test server and then 100% verify that it is actually what we are emitting to Kafka that we get into Elasticsearch. So let's try that. So inside of here, instead of saying Beatrice, what I'm gonna say is the username is ragazzo, and the mood is I want to shit. So actually, let me change it from ragazzo to Chris. Okay, so the username is Chris, the mood is I want to shit, and the message is it works. Okay, and now let's send a post request to our server using this request body. Okay, so I'll open a new tab. I'll run the test server again. So I'll run this. Then what I'll do is to search for all the things that I have inside of the index. So, and as you can see, I've got the first data that I put in Elasticsearch. So with the username Beatrice, and now the second data is Chris. Yes, it works. I want to shit, and obviously the emoji has been encoded, and I have the what I plan to achieve. So we now know that everything is working as expected. The next thing we are going to now is to build the React app. So the front end part of the application, and then integrate this application to React and then let the magic happen. Okay, so I'll see you in the next tutorial for that. So thank you guys for watching, and I'll see you in the next video.